autoregressive panel vector autoregressive model, and finally the dynamic panel data regression model. And you have also learned the static panel data analysis in your that was delivered by other resource person. Therefore, my task is quite easy. You are already have some knowledge regarding the panel data analysis. Not only that, you have also learned regarding the time series analysis. Okay, where you have learned the unit root test, co-integration test, vector error correction model, or vector autoregressive model in the time series framework. Now here I am addressing these issues in the context of the panel data. In the context of the panel data, as you have already learned the unit root test, co-integration test, error correction model, or autoregressive model. Therefore, I think I will discuss these 4 topics later. First of, I am trying to address the dynamic panel data regression model. This is the very new and advanced techniques to use the panel data regression model. One thing is important when we are using the static panel data regression model and when we are using the dynamic panel data regression model, this distinction is important. Not only that, why we are needed the panel unit root test, panel co-integration test, panel var, or panel autoregressive model, etc., etc. The basic reason is that if you are interested to analyze the short run or long run causality between dependent and independent variable, then you will also perform this unit root test, co-integration test, VECM, or var. But if you have you are only interested to analyze the relationship between dependent and independent variable, not the short run or long run causality, then you will do simple fixed effect model or random effect model that you have learned in the earlier session. Therefore, the purpose of this application is very specific. It is this application are only applicable where you are or we are interested to analyze the short run or long run causality. The short run and long run causality can be better addressed by using the panel data structure that I will discuss by the means of these 4 topics. Before that, first I discuss the dynamic panel data regression model. Okay. I come to that particular point, the dynamic panel data regression model, how we can distinguish the dynamic panel data regression model with other regression model. The participant, you are, I am audible to you. Hello. You can ask question whenever you need. The dynamic panel data regression model, how we can distinguish it from the other model. Actually, in every regression model, there are the dependent variable and independent variables. Okay. Suppose here YIT is the dependent variable and XIT is the independent variable. And this VIT and mu I, these are the random error term. Okay. This is the general structure of the panel data regression model. But in this general structure, if we consider this particular term, what is the particular term? Now it is YIT minus 1. What is YIT minus 1? Here YIT is the dependent variable. Therefore, the lack of the dependent variable becomes as an independent variable in this regression. This is the only condition for the dynamic panel data regression model. In case of dynamic panel data regression model, whatever may be your independent variable, whatever may be the nature of disturbance term, the condition is that the lacked independent variable becomes the lacked dependent variable becomes an independent variable. You may consider 1 period lag or you may consider 2 period lag. Generally, we consider 1 period lag. Therefore, by this equation, we can easily understand what is the dynamic panel data regression model. If we do not consider this YIT minus 1 term, this particular term, then the equation YIT equal to beta XIT plus mu I plus VIT, this equation is treated as the static panel data regression model. Hello?
Sir, you are not, your PPT is not visible, sir. Audible, but not visible.
PPT is not visible.
It is visible, sir. Visible. We can see it.
Okay.
Yeah, we can
Uh,
see.
Okay.
Perhaps it is your
Some
problem.
participants. Okay, sir.
In that case, if you will rejoin, then your problem may be solved. You will try to rejoin.
Okay, sir.
Okay,
Yes,
maybe
sir.
there is the problem of your software.
Thank
Okay,
you.
I think others participants, you are you are able to see my PPT. The YIT, yes, this introduction of YIT, the lag dependent variable as an independent variable in the regression model, treated the panel data regression model as a dynamic panel data regression model. But if you do not consider this term, then the panel data regression model is treated as the static panel data regression model. Now, when we introduce this lag dependent variable as an independent variable, the problem of endogeneity becomes in the regression model. Therefore, the nature of the regression model is quite different from the nature of the static panel data regression model. As the nature of panel data regression model is different, therefore the estimation procedure and treatment as well as interpretation of the estimated result are also different compared to the static panel data regression model. Okay, here you are already aware that in case of static panel data regression model, there are two alternative methods of estimation. As there are two alternative model, one is fixed effect model, another is random effect model. Fixed effect model is estimated by least square dummy variable method, whereas the random effect model is estimated by generalized least square method because of the nature of the disturbance term of these two model. Now, in case of dynamic panel data regression model, both LSDV method or GLS method are biased. If we will use these two methods, then the estimated parameter are not good, they are biased. Therefore, there are alternative methodology or methods of estimation for this particular type of model. And in this particular type of model, the appropriate method of estimation is generalized method of movement. Generalized method of movement. I think in your static regression analysis, static panel data regression analysis, you have already learned the least square dummy variable method of estimation for the fixed effect model, or you have learn the GLS method of estimation for the random effect model. Therefore, my task is only to discuss the general method of movement and how this general method of movement help us to estimate the parameter of this dynamic panel data regression model. Okay, and here the another condition that are needed, that is needed in this particular model to declare the model as a dynamic panel data regression model, or to use the dynamic panel data regression model by the method of GMM, is that here the number of cross-section observation is greater than number of time series specific observation. As it is a panel data, therefore it is a combination of the cross-section and time series data. Therefore, here the condition is that number of cross-section units must be higher than number of time series units. Okay. And this dynamic panel data regression model, or the techniques of the dynamic panel data, is estimated by a specific method that was developed by Arnello and Bond. Arnello and Bond, they developed the specific type of estimation of this type of model. And where they
Sir, sorry
introduced.
to interrupt, sir.
Yes,
Whether
sir.
changing the slides?
Yes.
Are you changing the slides?
No. I am in the first. My
Okay.
slide is dynamic panel data regression model.
Okay. Fine, sir.
It is visible.
It is
This
showing
slide.
advanced panel data analysis using EViews.
Okay. No. The slide. Why the slides are not changed? I am in the second or third slide. Okay,
No,
that
it's
is the
still
problem.
showing advanced panel data analysis using EViews.
So, what is the problem? Now I new share. I can start again. New share, then share my screen. Okay. Share my screen, then share.
Sir, you do the sharing again, sir. Let me close it. You do it now again.
Okay. So before that, perhaps I declare my PPT as a PowerPoint mode.
Vicky, please help if you're there.
Just 1 minute. Now I'm sharing my screen. Okay, panel data analysis or sharing my PPT.
Yes, Pinakida, share
Share
from
PPT.
share screen. Yes, now it is visible.
Now it is visible.
You may show the full slide.
Full slide, no issue. Full slide.
Fine, sir.
Yes,
Perfect. Perfect.
yes.
Achha, okay, now I
It is
second slide
visible.
is
Changing,
visible.
sir,
Yes.
changing.
Okay. Okay. Achha, this is the second slide. This slide also visible. Okay. Achha. No, I just in brief whatever I have discussed. Actually, I am planning to discuss before you these 5 important theories and their application in respect of the panel data. One is panel unity root test, panel co-integration test, panel vector error correction model, panel vector autoregressive model, and dynamic panel data regression model. And as you have already learned the time series analysis as well as static panel data analysis, therefore you have a little bit of knowledge regarding unity root test, co-integration test, VCM model or VAR model. Therefore, at first I will discuss the dynamic panel data regression model, as it is a very innovative and sophisticated type of regression model. Then I will discuss these 4 theories and their application in views. Actually, I have already discussed the dynamic panel data regression model. And now the screen is visible. Perhaps this is the regression equation of the dynamic panel data regression model. The equation is visible, Tarok sir?
Yes, sir, it is visible, sir.
Yes,
it is visible, sir.
Okay, good. Actually, in this regression equation, here we have introduced a particular term, YIT minus 1. This term is treated as the lagged dependent variable. YIT is the dependent variable, XIT is the independent variable. Therefore, here we introduce lagged dependent variable as an independent variable. And when we introduce the lag dependent variable as an independent variable, then the panel data regression model is converted into the dynamic panel data regression model. Therefore, if we are interested to distinguish between static panel data regression model and dynamic panel data regression model, the difference is that the introduction of the lagged dependent variable as an independent variable. If we do not consider YIT minus 1, this particular term, then the YIT equal to beta XIT plus mu I plus VIT. This is the static panel data regression model. Okay. And I have already mentioned that as we have introduced the lag dependent variable as an independent variable, therefore nature of the model is different. And as the nature of model is different, therefore the nature of estimation procedures are also different. You have already learned that in case of static panel data regression model, there are 2 types of alternative model. One is fixed effect model, another is random effect model. Fixed effect model is estimated by LSTV, whereas random effect model is estimated by GLS, that you have already learned. But these 2 estimation procedures are not applicable in this particular regression model because of the problem of endogeneity or introduction of the lag dependent variable as an independent variable. Now the question is, what is the appropriate method of estimation of this type of model? The answer is that general method of movement or GMM. This GMM is totally different compared to the LSDV and GLS. And another important features of this model is that when we are interested to use the general method of movement, then in case of panel data regression model, specifically in case of the panel data, the number of observation must be greater than number of time specific observation. N is the number of cross-section observation, T is the number of time series specific of observation in case of panel data. Therefore, this condition is also important, N greater than T. And in this particular type of model, that is the dynamic panel data regression model, Arnello and Bond, they have developed the estimation procedure by using the GMM. And in their version of the estimation of dynamic panel data regression model, they consider the lagged endogenous variable as well as the cross-section fixed effect model. The lagged cross-section fixed effect model means mu I. This mu I is treated as the individual effect. If we consider this as an estimable parameter, then it is called the cross-section fixed effect. Okay, now the nature of model is, I think you are able to understand the basic nature of the dynamic panel data regression model and what is the basic difference between static panel data regression model and dynamic panel data regression model. Now our task is to analyze or to estimate the panel data regression model by using the EViews. That is the application part. In my lecture, I mainly emphasized on the application part because due to the shortage of the time, I am not able to discuss in detail theory of estimation. Therefore, I will focus on the application of this estimation. One thing I have my views. I think you are quite familiar about the statistical software EViews. You have any question or in the chat box? You have some message. You can ask me also. PPT is not visible. Now it is visible. Okay. This is the EViews software. My first task is to open the data. Here we can open the data file from the file menu. Then there is the option of import of the data. I import this data from my MS Excel file. My data is in the MS Excel file. Therefore, I import the data from the MS Excel file. You can, if you are new in this software, then you can write the steps one after one. Then it will help you when you will apply it in your data set. My first task is to open the data file. File, then import file, import from file. Okay. My MS Excel file is available in this particular folder. Okay, panel data presentation, then FDP. This is the data file. I just open the data file. This data file consists with 4 sheets, with 4 sets of panel data. One data set related with poverty, and another is investment, another is FDI, and another is inequality. Gini. Gini is the measure of inequality. For the time being, I consider the 4th sheet in this Excel file, which is named as Gini. And when we are importing the data from MS Excel to EViews, as my task is to analyze the panel data analysis, therefore here we declare the data set to be the panel data. First of all, I select the appropriate sheet where my data is, and then it is next, all as usual. Next. In the 4th step, there is the option of the selection or declare my data set to be the panel data. There is the option, so many options are there. First of one option among them is the dated panel. And to declare the data set to be the panel data, two IDs are important. One is cross-section specific IDs, another is time series specific IDs. This is in my data sheet of Excel. This ID, I and D, this variable is treated as the cross-section specific variable, and whereas ER is treated as is named as the time series variable. Therefore, here I write the name ID as the cross-section ID series, and date series, that means time series, by the name ER that are already mentioned in my MS Excel sheet. Then finish. Okay. Here is the link imported series and alpha to external source. Yes or no? It is not the method. I consider no.
Sir,
yes.
Can you please show the EViews on the screen?
EViews is not visible.
PPT is visible.
PPT is visible.
When you share the entire desktop, then
I shared. Previously I shared the entire desktop.
Yeah,
in
if you
that
choose PPT,
slide,
then only PPT will be visible.
then the slides are not
So everything
changed.
will be visible, sir. You share the entire desktop,
Okay.
entire screen.
First of I shared, then I considered the
You first
screen.
you close it.
Ha.
First you close it. Let me close.
Okay.
Now you
Ha, ha, ha.
do sharing again.
Share is share my screen,
Yes,
then
sir.
share. Okay.
Yeah, now you do whatever you do, you can see, sir.
Previously I started. Okay.
Now both PPT and views will be visible.
Now the views is visible.
Visible, sir.
Okay. Achha, you have learned how we can import the data from MS Excel to views, or I repeat the transformation process of the data. Dear participants.
Sir, repeat from the beginning.
Okay, repeat from the beginning. No. Achha, this is my eViews software. I just opened the eViews software. The eViews software is visible now. In the top left corner, there is eViews, file, edit, object, view, etc. These menus are
Yes,
visible.
sir.
Okay.
Yes.
Therefore, my first task is to transform the data from MS Excel file to the eViews work file. Here under the file menu, there is the option of import the data. Here I consider it, import the data. Then I select import from file. Okay, my data is available in this particular folder. The folder is panel data presentation. Yes, under this folder. This is the MS Excel file where my data is available. Okay. And when we importing the data, we must remember that we declare the data set to be a panel data structure. That can be done. Here it is a 1 to 4 steps methodology to convert, to import the data from MS Excel file to workable file of views. In the fourth step, all are the remaining same. In the fourth step, there is the option, this is the fourth step, there is the option to selection the data as a, to declare the data set to be the panel data. Among this different alternative of the basic structure of the data, a particular alternative is available as dated panel. Dated panel is used to declare the data set to be the panel data. As it is the panel data, to declare the data set to be the panel data, two IDs are important. One is cross-section specific ID, that is I and D, which are available in my data set, and another is time series specific ID, that is ER. Okay, here we select these two variable. One is one in the box of cross-section IDs. What is the variable that identified as the cross-section variable in my data set? It is ID. Therefore, I simply write it ID. ID is the name of the variable for cross-section specification. And what is the name of the variable for time series specification in my data set? That is visible in the background. It is ER, YEAR. We write the name of the variable. These two IDs are important to declare the data set to be the panel data. This is the individual specific ID. This is the time specific ID. After writing this name of the IDs in these two appropriate boxes, now I can finish the transformation process. And this is the data. If I try to check my data, then I can open it. Open the data set as a group. Yes, this is the data set. Okay, this is the data set. Here, from 1995 to the data is available from 1995 to 2017, and number of countries apparently 70 countries. It is the data of inequality and as well as other macroeconomic parameter across 70 countries for the period of 1995 to 2017. Therefore, it is a very dense panel data. Okay, now my task is to estimate panel data regression model. To estimate the panel data regression model. Is that problem? Yes. As how we can estimate the panel data regression model? Not only panel data regression model, my task is the dynamic panel data regression model. Estimation of the dynamic panel data regression model, which is estimated by general method of moment. which is estimated by GMM. Therefore, how we can start? We start from the quick. Then there is the option of estimate equation. We have mentioned in the theory, there is the estimated regression equation, which is treated as the panel data regression model, YIT equal to YIT minus 1, etc., etc. Therefore, first task is to estimate the equation. Okay, this dialog box help us to estimate the panel data, the dynamic panel data regression model, to estimate the dynamic panel data regression model. Here, when we open this dialog box, at the bottom of this dialog box, there is the option of method. Under this method, there are different methods of estimation. Okay, here we select our appropriate methods of estimation or appropriate type of panel data regression model, that is called dynamic panel data. This option is available here, dynamic panel data or generalized method of movement, GMM movement. Okay, when we select this method of application, method of estimation, GMM, which is fit for the estimation of the dynamic panel data regression model, the dynamic panel wizard, this particular option is available at the bottom of this dialog box. Clear? If we select the as usual, then this dynamic panel data wizard is not visible. When we select the appropriate panel data regression model, that is GMM for the dynamic panel data, then this menu is active, dynamic panel wizard. This dynamic panel wizard help us to estimate to specify the dynamic panel data regression model. It is a step-by-step approach by which this dynamic panel wizard guide us a step-by-step incorporation of the different information to estimate the dynamic panel data regression model. Therefore, we select the dynamic panel data regression dynamic panel wizard. Now next, you can write the steps. First of all, we select the method, GMM or dynamic panel data, then dynamic panel data wizard. Then is considered next. Okay, it is it is a 6 steps. In different steps, we will provide different types of information to specify the dynamic panel data regression model. And at final stage, we will find the estimated result. At the first stage, in the stage 1, our task is to specify the dependent variable. Our task is to specify the dependent variable. What is the dependent variable? In this regression equation, here we consider Gini. Here the exercise is related in such a way that here we are trying to estimate the inequality across countries over time. And what are the factors that affects the inequality across countries over time? Here I have considered different types of factors, that is per capita income, GDP, an income indicator, then trade, volume of the trade, which is named by TRADE. There are other indicators like consumer price index, inflation, etc., etc. Therefore, for the time being, here I consider only GDP as the independent variable, only one independent variable. You can consider more than one independent variable, but for the time being, we consider the one independent variable, that is GDP. And what is the dependent variable? Now, the dependent variable is Gini. Gini is the dependent variable. Therefore, as we have specified in our model YIT, this Gini is the YIT and XIT is the GDP. Therefore, in the dynamic panel data regression model, there is the lag dependent variable there, and as you, therefore we consider Gini one period as the lag independent variable to treat the model as a dynamic panel data regression model. Here, our first task is to select the dependent variable. What is the dependent variable? Here it is Gini. I write the name Gini. Okay, and what is the number of lags? Here, for the time being, we consider only one period lag. There is the option of the selection of 2, 3, 4, 5. For the time being, we can select one period lag. That is related with my specified regression equation, YIT equal to YIT minus 1. That is one period lag. Accordingly, here I consider one period lag. Then next. This is the second step. Okay, these steps if we are able to complete these particular steps, then it help us to incorporate the explanatory variables. All are written here. You may specify the regressors. Regressor means the explanatory variables. In our model, the explanatory variable, or in our example, the explanatory variable is say GDP. Other than the lag dependent variable. Here we do not consider the lag dependent variable, rather we only consider the regressor or explanatory variable, that is XIT. And the independent variable is written as GDP. In the left hand screen, we can here it is visible that GDP is a variable. Therefore, we just write the name of the variable GDP as an independent variable. Side by side, here we also consider the period dummy. The period dummy, that is the period fixed effect, to address the fixed effect or period fixed effect, that is time fixed effect, time specific fixed effect. Here we consider the period dummy. Then next, it is the step 3. It is the step 3. These steps is help us. It is actually transformation. And what types of transformation we consider in our model? Here we may consider the difference method or orthogonal deviation method. Both are applicable, but researchers generally used the orthogonal transformation or orthogonal deviation method. Here we consider orthogonal deviation method, and there is another option that is do not transform the period dummy variables. We are interested to analyze the impact of the period dummies. Therefore, we do not transform the period dummy variables. Therefore, it is as usual. Then next, that is the fourth step, and this fourth step is the incorporation of the lag dependent variable. Is the incorporation of the lag dependent variable. Here, Arnello and Bond, in these types of dynamic panel data regression model, they have considered an instrument, lag dependent variable as an instrumental variable in the regression model. Lag dependent variable as an instrumental variable in this regression model, which is treated as, which is written as at the rate dyn Gini, -2 second period lag. Second period lag is the another instrumental variable in the model as specified by the Arnello and Bond in their estimation techniques. Okay, now is next. Okay. It is the step 5. In this step, you should now specify the remaining instruments. There are 2 lists. You can see there are 2 lists. One is the transform orthogonal deviation. We have considered this methodology for transformation, and another is no transform. Here we are interested to transform all the instrumental variables, instrumental variables. That is all the variables. What are the instrumental, the remaining instrumental variable in this model? In the current specification of the model is that here the dependent variable YIT or Gini is the dependent variable. This is the current specification of the model. Gini, then Gini -1 and GDP. Gini -1 and GDP. That is Gini is the dependent variable, Gini -1 is the independent variable, and GDP is the dependent variable. Therefore, the first list, which is entered in the edited field labeled as transform, should contain the list of the strictly exogenous instrument that you use to transform prior to use the estimating the transformed equation. And in the second list here, it is the no transformation edit box. And here we enter the all variable, that is GDP and Gini -1, all the instrumental variable. Gini -1 that is lagged one period, as well as GDP. All the independent variable, Gini, one period lag, and GDP. Then next, this is the final step of the estimation. Here it is the GMM estimation, two-step estimation, and the particular type of estimation is a white period. We select this white period as well as two-step estimation of the GMM iteration. Next, our tasks already complete. That is the task of the selection of the specific model, that is selection in the dynamic panel model wizard. Then finish. This is the model that we have specified in the dynamic panel data regression wizard. One is Gini, then Gini -1, GDP, along with here we have considered the instrumental variable as well as the time dummy variable. Okay, the selection of the model is fine. Now here we consider the panel option. The panel option. In the panel option, the cross section. In case of cross section, here we have already considered orthogonal deviation, and in case of period, here we consider fixed dummy. Therefore, it is the fixed by default. The panel selection panel option, the software consider orthogonal deviation as we have selected in the panel dynamic data wizard, and for the period it is fixed. Okay, and for estimation procedure it is GMM weight. GMM weights, the weights is white period as specified by Arnello and Bond. Okay. Okay, Gini -1, there is the syntax error. We go to the panel data wizard. As a dynamic panel data wizard, next, that the specification of the instrumental variable here. Okay, here it is the GDP and instrumental variable are mainly the independent variable regressors, but here you consider Gini. No, all independent variables are considered as the instrumental variable. One is GDP and another is one period lag. Therefore, it is one GDP one period lag, not Gini one period lag, rather GDP one period lag. GDP one period lag and GDP. Okay. Next, all other remaining same. Okay. Okay, GDP -1. What is the problem? One thing. I go to the dynamic panel wizard, then Gini is the dependent variable, GDP is the independent variable, include period dummy, that is the second step. The third step is the orthogonal deviation. The fourth step is the Arnello bond type instrumental variable, that is all automatically taken by the software and specified its name by @dyn Gini -2. Then next, this is the remaining instrumental variable. Okay, first up we write the GDP, then GDP -1, GDP, then GDP -1. Next, Yes. First we write the original variable GDP, then the 1 period lag. This is the estimated result. This is our estimated result. It is in this estimated result, these are the coefficient table, and at the bottom of the result there are the summary statistics. Here we have considered 1 period lag, Gini -1. This is as an independent variable, and GDP it is the lag dependent variable as an independent variable, and GDP is the only one independent variable. And these are the time fixed dummy. Here we have considered time fixed time for the period 1997 to 2017. Therefore, all are the coefficient of the time fixed dummy. These are estimated coefficient, standard error. The coefficient divided by standard error equal to T statistics, and these are the level of significance, that is probability. Here the Gini -1, the level of significance of lagged independent variable is 0.000, that is statistically significant. But GDP is the probability of GDP is 0.089. The level of significance is 0.089, which is higher than 5%. It is 8.9%. Therefore, GDP is statistically insignificant. Some of the time damage are statistically significant, some are the insignificant. In the model, you can consider other independent variable if you want to incorporate as you in your model. And here you can see that here the instrumental specification that this is by default considered by the model, which is the by the software Gini -2. And again, we considered other two instruments, GDP and GDP -1, as well as the fixed dummies, fixed time dummies. The summary statistics at the bottom of the dynamic panel data regression model estimation, estimated result of the dynamic panel data regression model, specifically the J statistics and its probability, as well as instrumental ranks. These two are important to understand whether the estimated result is statistically significant or not. If in case of instrumental rank, if the instrumental rank is higher than number of estimated coefficients, then the model is quite good. Side by side, if the J statistics is statistically significant, the value of J statistics is 85.60, and its level of significance, which is mentioned here by probability J statistics, equal to 0.000, that is significant value. Therefore, we can say that here J statistics or J test is statistically significant, which implies that the model is good fit at 1. As in our simple regression model, F statistics or F test is, if F test is statistically significant in case of classical linear regression model, simple regression model, then we call that the model is good fit at 1. Similarly, in the dynamic panel data regression model, if J statistic or J test is statistically significant, then we can say that the model is good fit at 1. Okay. This is all about the estimation of the dynamic panel data regression model. If you have any query, then you can ask me.
Sir, you had said that N should be greater than T.
Yes, yes.
Here, all the level that you are showing below GDP and all. So, is they counted or?
N means as it is a panel data, it is a combination of cross-section and time series data. What is the cross-section observation in your panel data? That is the number of N. And what is the time series observation? That is T. Here number of N is greater than number of T. In my present data, here I have considered the information of 70 countries for the period of say 20 years, say. Therefore, as it is the information of 70 countries, therefore number of cross-section observations are 70, that is N equal to 70, and the number of time-specific observations are 20. Therefore, 70 greater than 20, that is I call N greater than T. Is it
yes,
clear?
And then instrument rank has come at 72.
72.
So it's greater than N.
It is 72. If the number of cross-section observation is relatively small, then obviously instrument rank is lower than the estimated coefficient. Here estimated coefficient is 20 plus 222. If a number of observation relatively small, then here the instrumental rank not greater than the number of estimated parameter. In that case, we treated that the model is not good fitted one. That is why we impose that condition, the n greater than t. Number of cross-section specific observation must be greater than number of time specific observation. Okay, is it clear?
Yes, sir.
Okay, okay. Achha. Other participants, if you have any query. Hello. Achha, you are able to understand the step-by-step procedure of the estimation of the dynamic panel data regression model? Yes or no?
Yes, sir.
Yes, sir. Okay, good. Achha, now I will discuss the other theories and their application. That is panel unit root test, panel co-integration, panel VAR, and panel VCM, panel vector error correction model. Before estimation of these theories or this model, let us discuss the basic ideas regarding this specific concept. This concept, that is first of the panel unit root test. Have you any idea about the unit root test? Yes or no? Have you any idea about unit root test? You have learned in your time series analysis. Anybody can answer. What do you mean by unit root test? Hello. Okay, it is my task. Let me discuss the issue of the panel unit root test. In case of, sorry, the PPT is visible now. Hello.
Yes, sir, it's visible.
The PPT is visible. Okay. You have learned the time series unit root test. Yes or no? In the time series analysis. No, don't remember. That's okay. Actually, whatever may be the data, when the information varies over time, either in case of time series data or in case of the panel data. In case of panel data, there are two dimensions. One is cross-section, another is time. Therefore, there is also the variation of the time-specific observations. Now, in case of if the data varies over time and we are interested to use this data in our regression estimation to find the causality between dependent and independent variable, then we must check the unit root test and co-integration test. Actually, in case of unit root test, our task is to test whether the data, that means the variable, is stationary or not. Here we formulate the hypothesis. As it is a test, therefore hypothesis is also attached in this particular test. In the panel unit root test, we construct the hypothesis in such a way that the null hypothesis is non-stationary, whereas the alternative hypothesis is stationary. Non-stationary means the panel has unit root, and stationary means the panel has no unit root. What is stationary? Stationary means if we shift the time, if we change from one time period to another time period, that does not cause the change of the shape of the distribution. That is called the stationarity. Suppose for a particular year to 1997, the shape of the distribution of the data, and if you consider the shape of distribution for the next period in the year 1992, if the shape of distribution of these two periods of the data are same, then we can say that the data follows, or of the particular variable follows the stationarity, and the panel data has no unit root. Similarly, if you consider only time series data, then it is a similar argument. A non-stationary, that is panel time series has unit root, and under the alternative hypothesis, time series data have no unit root. Now, to consider the dependent and independent variables, or to find out the short run or long run causality of the dependent and independent variable at the level means at the original data, the data is non-stationary. But when we consider its fast difference means successive difference from one period to another period, then it is the stationary. That is no unit root. You understand what is the level of a data set and what is the fast difference of a data set? Suppose I have a data Gini or GDP. Then what is the level of the GDP? Then what is the fast difference of the variable GDP? Yes or no? Hello. Achha, am I audible? Hello.
Yes, sir.
Okay, audible. Achha, now I am asking you a question. Whether you are, suppose this is a particular data set, my original data set in MS Excel sheet. The data set is visible in a MS Excel sheet, yes or no?
Yes, sir.
It is visible. Suppose I consider particular variable GDP. Okay, then what we understand that particular variable GDP at level and GDP at fast difference. Have we any idea or not? GDP at level means the original information which are available from 1995 to all the period to 2017, etc. for different time period, for different observations, for different cross-section IDs. The original data that we have collected is treated as the GDP at level. But what is the GDP at fast difference? What is the GDP at the fast difference? We write it GDP minus 1. What is the GDP at fast difference? GDP at fast difference means it is the successive difference from one period data to from its previous period data. That is, if we subtract this data, GDP of the year 1996 and the GDP of the year of the previous year, then this difference, this is the successive difference between two periods of data. Then this value is the value of the GDP minus 1, GDP of the fast difference. Similarly, we can write this formula for all the values. Here, this is the difference between GDP of the year 1997 and its previous year 1996. This is called the GDP minus 1. You can estimate the GDP minus 2 in my regression model that I have already estimated. The Arnell and Bond consider GDP minus 2, second difference. What do you understand by second difference? GDP, minus 2. Second difference means again the difference of successive difference of the first difference. That is, if we subtract this value and its previous value, then this particular value is treated as the GDP minus 2. In this way, we are calculating the GDP at the first difference, GDP at the second difference, and the original data that I have arranged is the GDP at level. Is it clear? What you understand by a particular variable at level, at first difference, and at the second difference? Yes or no?
Yes, sir.
Okay, good. Now we come to the particular theory that is panel unity root test. In case of panel unity root test, the null hypothesis is non-stationary and the second alternative hypothesis is stationary. And what is our expected outcome, desired outcome, to find out the short run or long run causality between dependent and independent variable? Now our expected outcome or desired outcome is that at level, that means at original value, it is the null hypothesis. They are non-stationary, and at the first difference, they will be stationary. That is the alternative hypothesis is true at the first difference. Now, alternative test statistics are available that was developed by different statistician to test this panel unit root test. Okay. Now the second criteria is the panel co-integration test. That is another test to understand the long-run causality between dependent and independent variable. If we are interested to understand whether this GDP and say export is another variable, volume of export, there is any long-run association or not between these two variables, then we perform the panel co-integration test. But to perform the panel co-integration test, the precondition is that my data is non-stationary at level, but it is stationary after the first difference. That is non-stationary at the original data, and when we transform it at the first difference, then it became the stationary. It will be stationary. That is the precondition. If the data particular variable follows this condition, that at the level it is non-stationary, this a particular variable, and after making the first difference it is stationary, then only we can perform the panel co-integration test. In case of panel co-integration test, both the dependent and independent variable, or in two or more variable that we are interested for panel co-integration, must be integrated at the same order. Must be integrated at same order means, suppose GDP is a particular variable, it is at level non-stationary, and at the first difference it is stationary. Whereas if you consider Gini, then we will see Gini is the stationary at the level. That is Gini is a particular variable which is stationary at the level, whereas GDP which is stationary at the first difference. Therefore, order of integration of these two variables are not the same. Therefore, we are not able to find out the long-run causality or long-run association between these two variables, Gini and GDP. Therefore, that is also another condition that the variable must be co-integrated at the same level. That is, both are stationary at the first difference, or they are stationary at the second difference. In most of the cases, in 99% cases, the variable are stationary at the first difference. Some of the variable may be there which are stationary at the after transforming it at the second difference. Okay. In case of panel co-integration test, here our null hypothesis is no co-integration, and alternative hypothesis is co-integration. No co-integration means there is no long-run association between these two variables, and co-integration means there is long-run association. And this panel co-integration test can be performed by alternative test, Pedroni test, Cow test, and Fisher-Johansson co-integration test. We will analyze, we will apply this test to understand the panel co-integration test. Now, if we consider these two tests for a particular data set, first of unit root test and then the panel co-integration test, and after the performing these two tests, if we will see that say two variables, they are co-integrated. They are co-integrated means they are the stationary at the at the first difference, and they are also fulfilled the co-integration test. Then we can apply a particular model. The model is called a vector error correction model. But if the two variables are not co-integrated each other, then we can apply the vector error correction model. That is, on the basis of the result of unit root test and co-integration test, we can select appropriate panel data regression model. If the two variables are co-integrated to each other, that is satisfy the co-integration test, then my selected model is vector error correction model. If for a particular set of data, if the variables are not co-integrated each other, then we consider vector error correction, vector autoregressive model. Next two slides describes these two alternative model. First one is the vector error correction model. To perform or to understand whether the model is vector error correction model or not, the precondition is that the two variables, one is dependent, another is independent, or several variables, one is dependent and more than one independent variables. They are non-stationary at level, but stationary at the fast difference. Side by side, these variables are co-integrated each other. Dependent and independent variables are co-integrated each other. If they are stationary at the fast difference and co-integrated each other, then the estimated panel, then the panel data regression model is treated as the vector error correction model. In case of vector error correction model, we are able to estimate both short-run causality as well as the long-run causality. That is the purpose of this estimation. In case of static panel data regression model, we are not able to estimate short-run and long-run causality between dependent and independent variable. But these types of exercise help us to understand or to estimate the short-run and long-run causality. Now, under the vector error correction model, we are able to estimate short-run and long-run causality, and we are also able to a particular test is there, which is called the wall test, that help us to understand whether the joint effect of the short-run period is significant or not on the dependent variable. Similarly, there is another model that is called vector autoregressive model. In case of vector autoregressive model, the variables are stationary at the fast difference, but if they are not co-integrated, then the panel data regression model is treated as the vector autoregressive model. And in case of vector autoregressive model, we are only able to understand the short-run causality or able to estimate the short-run causality, not the long-run causality, because to estimate the long-run causality, the precondition is that the variables having with long-run association, that is, they satisfies the co-integration test. But if they are not satisfied by the co-integration test, no co-integrated, then we are only able to estimate short-run causality by VAR. And there is also the option of the wall test to estimate the joint effect of the different cross-section or different short-run periods on the dependent variable. Okay, that is our now we can apply this methodology. That is panel unit root test, panel auto correlation, or panel co-integration, panel unit root test, panel co-integration, VCM model and VAR model with the help of the EVUge software. I think you are able to understand the theory behind the theoretical understanding behind the panel co-integration test, panel unit root test, vector autoregression model, and vector error correction model. Have you any query regarding this concept? Hello? No. Now it is my application part. I go to I open the software, EVUge software. This is the EVUge software. I have already imported the data related to the Gini inequality and other macroeconomic indicator across countries over time. Now my task is to estimate the panel unit root test, panel co-integration test, VCM model, and VAR model. Okay. Have you understand the concept regarding panel unit root panel auto co-integration, VCM, and VAR? Yes or no? The theoretical concept of these techniques.
Yes.
Have you any query? No. Okay, we can proceed. Our first task is the panel unit root test. Okay, panel unit root test. You can perform these types of tests in another software like State or R, but EVUge is quite easy to perform these types of techniques. First task is the panel unit root test. So this is my data. Data is available. I have already transformed the data. There is the option of quick. Okay. You write in your copy the application. Now I am trying to apply the panel unit root test in eViews. I start from quick, then series statistics. Series means variable related statistic. Variable related statistic is treated as the series statistics. Under the series statistics, there is an option which is called unit root test. Unit root test. We consider the unit root test, and as it is the panel unit root test, because I have already declared my data set as a panel data. If you are not declared your data set is the panel data, then actually it is the time series specific unit root test. I have already declared the panel, the data set as a panel data. Therefore, when I select unit root test, it actually panel unit root test. Unit root test, there is the option of the selection of the variable. Suppose you consider particular variable, say GDP. GDP is a variable. Okay. So when you select GDP as a variable for panel unit root test, there are alternative test criteria, alternative test methodology. Alternative test type means several econometrician or statistician, they have developed alternative methodologies, but the purpose of the methodologies are the same, to check the panel unit root. What are the alternative methodologies? First one is the Levin-Linchu method, Bruting method, IM Pesran-Srin method, Fisher augmented Dickey-Fuller test method, Fisher Phillips-Perron test method, and Hadri method. So many methods are there. Among the 6 alternative methods that are available in eViews software, if you consider the first 5, then in the first 5 types of method, the null hypothesis is non-stationary and the alternative hypothesis is stationary. Whereas in case of Hadri, he designed his test statistics in such a way that in case of Hadri types of methodology, the the null hypothesis is stationary, whereas alternative hypothesis is non-stationary. Okay. That means among these 6 states, 6 type of estimation procedure, in the first 5, if the null hypothesis is rejected, then we call the variable is stationary. But in case of Hadri test, if the null hypothesis is not rejected, then we can say that the variable is stationary. There is not enough time, therefore I do not consider all the methodology for the time being. You will try for your data set. Here by default I consider summary statistics. Summary means the software consider some selected methodologies among these 6 alternative types of panel unit root test. That is the selection of the test type. Another method is another step is the selection of the unit root. That is unit root at the level, or unit root at the first difference, or unit root at the second difference. Unit root at the level means unit root at the original variable, original data. And first difference means after transforming the data set to be the first difference. Okay, first of I considered at the level, GDP at level, that means GDP at the original data set. Third step is the include in test equation. In my test equation, the regression equation, whether there is only individual intercept or both individual intercept as well as trend, or none, no individual intercept and no trend. 3 alternatives are there. You will check this 3 alternative one after one, but for the time being, due to shortage of the time, I consider only the first, individual intercept. The 4th step is the lag length, selection of the lag length. That is the advantages to apply the eViews in case of panel data analysis. In eViews software, the automatically selects the lag length. There is so many criteria by these criteria, reviews automatically select the lag length. Here, the fourth step is to select automatic selection. Automatic selection, and the method is the by default sewerage info criterion. This method we are using to select the lag length. Okay, that is the fourth step. First step is the selection of the test type. Second is the test for unit root for level or fast difference, and third is the what is the test equation, whether we consider intercept or both intercept and trend or none, and fourth is the lag selection, which is automatic in case of EVUs. Now, okay, this is the result. This is the result of the panel unit root test. In the bottom, there is the heading of this test result, which is stated as the panel unit root test, and the series, what is the name of the variable? GDP. GDP is the name of the variable, and for the period 95 to 2007, etc., etc. This is the result of the panel unit root test of the GDP. Okay, here as it is the summary statistics, therefore software considers some specific types of methodology. First one is the Levin-Lin-Chu, then IM pace run, Fisher augmented Dickey-Fuller, Fisher chi-square. Among these 6 alternative methods, under the summary, there are 4 alternative methods: Levin-Lin-Chu, IM pace run strain, and Fisher augmented Dickey-Fuller, and Fisher Phillips-Perron test. And there are the result of this test statistics. This is the estimated value of the test statistics, corresponding probabilities. On the basis of the corresponding probabilities, we are able to understand whether these tests are statistically significant or not. If the value of the probability is less than 5%, if the value of the probability is less than 5% for a particular statistics, then we can say that this test is statistically significant. If you consider first, say, Levin-Lin-Chu method, the estimated value of test statistics 5.84, and its level of probability, that the level of significance, is 1.00. What is the this is the level of probability? If we transform into the percentage form, then we multiply it by 100. Then it is actually 100%. Our level of significance, the threshold value for the level of significance is up to 5%, 1%, 2%, 0.1%, up to 5%. If the level of significance is more than 5%, then we can say that the test is not statistically significant. For the larger value of the probability, here we argued that the Levin-Lin-Chu method is not statistically significant. Similarly, IM Pestan Scene method, its value is also 100, that is 100%, not statistically significant. But in case of augmented Dickey-Fuller test, Fisher ADF, whether it is statistically significant or not? What is your answer?
No, sir.
It is statistically significant or not? No.
Not so.
Why? Because the level of probability is the value 0.97. When
90.
we turns 97%, good, 97%. Our threshold value is, maximum threshold value is 5%. Therefore, all 4 tests are statistically insignificant. If all these tests are statistically insignificant, then we can say that the null hypothesis is not rejected. What is the null hypothesis of unit root test? It is non-stationary. It is non-stationary. As I have specified earlier in the PPT, the null hypothesis in unit root test is non-stationary. And here the result of the test statistics show that all tests are statistically insignificant. That is, null hypothesis is not rejected. That is for the variable GDP. For the GDP variable at the level, it is non-stationary. Now we will check it whether it is non-stationary or stationary at the first difference. Okay, as I have already selected the name of the variable, therefore I start from here. I can continue from here. View. Under the view, there is the option of unit root test. Okay, I have already selected all the options as well as the series, that is name of the variable. Now I am interested to test panel unit root at the first difference. That is, after transforming the variable of the first difference, I am interested to find to test the panel unit root. Previously, it was at level. Now I consider first difference. All other thing as it is, as I have considered earlier, individual intercept, automatic lag selection, etc. Then okay. This is the result of the panel unit root test. What is the variable? DGDP. DGDP means it indicates the first difference of the GDP. D for difference. D, this is the name of the series. Previously it was GDP. Now it is DGDP. That is difference of GDP. First order difference of GDP. And what is the result of alternative test statistics? What you understand from the result of alternative test statistics, whether this test are statistically significant or insignificant?
Significant.
Significant, because the probability of all tests are 0, 0, 0, 0, 0, 0. Therefore, they are statistically significant. Therefore, what is our conclusion? The GDP at first difference is stationary or non-stationary? GDP at the first difference is stationary or non-stationary?
Stationary.
Stationary. GDP at the first difference is stationary because as the test result is statistically significant, therefore null hypothesis is rejected. What is the null hypothesis? Null hypothesis, this is, I can try to coordinate with the theory. The null hypothesis is non-stationary. Alternative is stationary. As the all the tests are statistically significant, therefore at first difference, therefore null hypothesis is rejected. Alternative hypothesis is accepted. Alternative hypothesis is stationary. That is why we can say that when the tests are statistically significant, the variable is stationary. Okay. It is fine. You are able to understand the concept of the panel unit root test for a particular variable.
Yes, sir.
Yes, good. Now I consider another variable. But here so many other alternative methods. I have only considered only a few methodology. What are the alternative method? As I just first of I consider summary methods, not the all methods. Then in case of estimated equation, test equation, there are three alternatives. I only consider individual intercept. You will also try for individual intercept and trend and none. And you will find so many results of test statistics on the basis of the of this all result of the test statistics. What is the majority result? If the majority result indicate that null hypothesis is rejected, then we can consider the variable is stationary. The variable is stationary. And when you will perform all the tests, some of the test statistics may not be statistically significant. But if most of the test statistics, most of the result are statistically significant, then by the majority rule, we can consider that this particular variable is stationary at the first difference. Similar argument also true for the level. If you do not interested to other methodology, then it is quite fine. You consider only summary, then either level or first difference or only individual intercept. And now our task is to estimate the
Co-integration.
no, other variable. For the co-integration, two variable must be co-integrated at the same order. We have checked that GDP is co-integrated in order 1. Order 1 means at level, that order 0, it is non-stationary, but after the first difference, it is stationary. We can say that GDP is co-integrated, GDP is stationary at level 1. Okay, now I consider another variable, say trait. Trait is the another variable. Then we start from quick, then unit root test, series statistics, then unit root test, then it is GDP, not GDP, rather trait, volume of trait, TRAD. Again, there is the summary. First of all, I consider level or all other thing as before, individual intercept and automatic lag selection. This is the result of the panel unit root test of another variable trait. What is the result of this variable? Therefore, I consider this particular variable. Here, the Levin-Lynch method, is it statistically significant or insignificant? It is statistically significant. Okay.
Significant.
And IM Pesran-Shin method?
Significant.
It is also significant. But augmented Fisher ADF, augmented decay Fuller or Fisher Phillips Perron, they are not statistically significant. Therefore, 50-50 rule. আমরা majority selection করতে চাই, we are interested to find out the majority decision, but here 50-50 rule. মানে two results are statistically significant, two are statistically insignificant. We are in the dilemma. Therefore, we consider other alternative. Other alternative, unit root test, say other type of test, or say for individual intercept and trend. This is the result of individual intercept and trend. Okay. What is the result of when you consider, when you change the nature of the equation? Levin-Lynch method is statistically significant. Here, IM Pesran method is not statistically significant. Again, augmented decay Fuller Fisher test is also statistically significant. 50-50. Therefore, we consider more test. More test means suppose in case of none. That is why there are alternative test equation and alternative method. In case of none, yes, all three variables are, or all three tests are statistically insignificant. That is, so far we have estimated 4 plus 4 plus 3. That means 4, 4, 8, 11 results. And out of this 11 result, 2 plus 2, that is 4, are statistically significant, but other are statistically insignificant. Therefore, by the majority rule, we can say that the majority of the test results are statistically insignificant for the variable trait. That is, for the variable trait, it is non-stationary at the level. It is non-stationary at the level. Are you able to understand this logic that I am trying to say before you? Hello. Hello.
Yeah, out of 11, 7 are saying that it is insignificant.
No, in case of only trend, there are 4 results. In case of trend both and intercept, there are again 4 results. And in case of non-type of equation, the no intercept and no trend, there are the 3 results. Therefore, in 3 alternative types of specification of the equation, we have 4 plus 4 plus 3, 11 total results. In the first stage, first step, out of 4, 3 are statistically, 2 are statistically significant. In the second type of equation, out of 4, 2 are statistically significant. And in the third type of equation, out of 3, 3 are no one is statistically significant. Therefore, out of these 11 results, only 2 plus 2, 4 are statistically significant. And the remaining 6 or 7 are statistically insignificant. Therefore, by the majority rule, we can say that 7 out of 11 test results are statistically insignificant, and that is why we consider the trait variable is the stationary, is non-stationary at the level. Okay. Now we check it whether it is stationary or not at the first difference. You need to do test at the first difference, starting from individual intercept. Yes, what is the result? It is the trait D. D means transformation, first transformation of D trait. And at the first difference level, all the test results indicate that they are statistically insignificant or significant. They are statistically significant. They are statistically significant. That is why we can say that after the first difference, trait is stationary. That is statistically significant means null hypothesis is rejected, alternative is true, alternative is the stationary. Now we can, if we have all tested the unit root test of the two variable. One is GDP, another is trait. For both the variables at the level, they are the non-stationary. After making the first difference, they are the stationary. Now, these two types of series are now treated as the integrating order one. Integrating order one. Integrating order one means at the first difference, both are the stationary. When the series are integrating in the same order, we can able to check the co-integration, whether they are co-integrated or not, whether these variables, whether there is any long-run association or not between the variables or among the variables. Now our next task is the panel co-integration. Our next task is the panel co-integration. Okay. Have you any query regarding panel unit root test? No. Now we can proceed. The panel. Yes.
Excuse me, sir.
Yes.
So for taking the panel unit root test, do we have to take the log of the series? And if we do so, what is the advantage of?
Yes, log of the series. You can consider log of the series. Then this data is treated at the level. This data is treated as the level. Where you consider the log. Now, if you see in your data for a particular variable, the observations are varied widely. There is wide variation of the observation. In that case,
sir, I can't hear you, sir. Please.
Hello. If in a particular data set for a particular variable, if the observations are widely varied, in that case, to reduce the variability of the observation, we transform the data into the log form. Other purpose are also there. The log form of equation has some specific interpretation. That is why researcher consider log-log model or semi-log model. That is another reason. But you can transform your variable into the log form. Not the issue. Okay.
Thank you, sir.
But this log form of the variable is treated as the at the level variable at the level. Okay. Now the panel co-integration test. What is the test statistics for the panel co-integration? There are also alternative test statistics: Pedroni, cow test, Fisher-Johansson co-integration. We consider this one, Fisher-Johansson co-integration test. Not it is most important, but all are the important. Researcher in most of the cases they have applied the Fisher-Johansson co-integration test. But it is better if you consider alternate all the tested and what is the result after the all test. That is more important rather than your inference on the basis of particular test. In case of panel co-integration test, there are two. The null hypothesis is no co-integration, and alternative hypothesis is co-integration. And the what is the precondition? Precondition is that both the variables are stationary at the first difference. Stationary at the first difference. We start from here. Quick. Then previously under the series statistics, the unit root test option is available, but now I select the group statistics. Under the group statistics, the co-integration test is available, Johansson co-integration test. But under this test, all alternative type of tests that I have mentioned in the PPT are available. Johansson co-integration test. First of all, specify the variable. GDP is the variable. Another is the trait, TRAD. These are the variable. You can check the spelling of the variable. Trait, another is the GDP. Okay. This is the panel co-integration test dialog box. Under the test type, there are alternative methods for co-integration test, as I have mentioned in my PowerPoint. Pedroni test, cow test, and Fisher-Johansson co-integration test. We can select any one or all the test. For the time being, I select Fisher Johansson co-integration test, and under the Fisher-Johansson co-integration test, in respect of deterministic trend specification, there are so many options, 5 alternative options. Among these 5 alternative options, you can select any one, or you can check your result for all the 5 alternative type of deterministic specification. Here I consider the all sorts of specification are there, intercept is there, trend is there, etc., etc. Therefore I select the type 4, but you can select 1, 2, 3, 4, 5, all the tests. For the time being, I consider it is 4. The lag interval by default, if you consider 1 lag. Okay. This is the result of the Johansson-Fisher panel co-integration test. What are the variable? 2 variables, GDP and trade. GDP and trade, these are the 2 variables. And what are the test results? This is the test result. And now the important is to interpret how we can interpret this test result. There are 2 lines. One is in respect of none, another is in respect of at most 1. This is the hypothesized number of co-integrating equation, CES. CE means co-integrating equation. CE stands for co-integrating equation. As you are interested to find out the co-integration between these 2 variables, therefore, whether there is any co-integrating equation or not, that is specified, that we can understand from these tests. And none means no, there is no co-integration test. What is the in this test here under the none, the Fisher statistics for trace test, and the value is 259, its probability is 0.000, that is statistically significant, that is null hypothesis is rejected. Whereas in case of another test statistics for maximum eigen test, the value is 232.5, very high value, and the level of probability, level of significance is 0.000. That is the Fisher's, that is, it also statistically significant. Both the test result under the none are statistically significant, that is null hypothesis is rejected. Null hypothesis rejected means null hypothesis is, yes, there is co-integrating equation. There is co-integrating equation. In case of Johansson panel co-integration test, the null hypothesis is, yes, there is co-integrating equation, but here the none means all the test statistics are statistically significant. Therefore, null hypothesis is rejected. But if you consider at most one line, then it is in that at most one means at most one co-integrating equation. Here the null hypothesis is. Here the tests are statistically insignificant. Here both the tests are statistically insignificant. That means null hypothesis is not rejected, which implies that there is at most one co-integrating equation. At most one co-integrating equation. Therefore, to understand whether the variables are co-integrated or not, simply you can judge that at the level of none, these statistics are significant, whereas at the level of at most one, they are statistically insignificant. It indicates that there is at most one co-integrating equation. That means GDP and trade, they are co-integrated each other. There is the long run association between GDP and trade. Is it clear? In this way, we can check the co-integration test. But here I have considered only one method, Johansson-Fisher co-integration test. There are other alternative methods. You will check that also in your data case. For the time being, I am not able to check all the methods. Now I consider.
Yes. Repeat the interpretation.
Interpretation. For the interpretation under the none means no co-integrating equation. None means no co-integrating equation. The test statistically significant. That means the null hypotheses are rejected. Null hypothesis rejected means null hypothesis is none. That means no co-integrating equation. This criteria is rejected. Similar argument you can put here at most one. That means at most one co-integrating equation. This is the null hypothesis. And here the test is statistically insignificant. That means null hypothesis are not rejected. Therefore, we can say that if these types of result for a particular set of variables, we can say that they are co-integrating each other. Or simply you can remember in this way, at the level of none, all the tests are statistically significant, but at most one, at the level of at most one, they are statistically insignificant. Here none means no co-integrating equation. This is the heading, hypothesized co-integrating equation. That is the heading of these two lines. None means there is no, hypothesis is that there is no co-integrating equation. This is null hypothesis, and it is statistically significant. Null is rejected. That means this statement is not true. Whereas at most one, this is the hypothesized criteria. Here alternative, here the test statistics is insignificant. That means null hypothesis is not rejected. That means the hypothesized condition is true. There is at most one co-integrating equation. This implies that GDP and trade are co-integrated each other. There is the long run association between GDP and trade. Okay. Now, if you consider these two variables, GDP and trade, then they are integrated at order 1, side by side. Side by side, they are also co-integrated each other. They are also co-integrated each other. If these two conditions are fulfilled, then only we can judge whether there is any long run association or not between these two variables. And this long run association or short run association can be judged by these two models that we have specified earlier. One is vector error correction model, VECM, and another is vector autoregressive model. In case of VECM, here you see these two conditions are fulfilled. Three conditions are stationary or fast difference, as well as variables are co-integrated. And this model helps us to judge whether the variables are whether there is any short run or long run causality or not. Now we can try to estimate the panel vector error correction model. Okay, for these two variables, panel vector error correction model. We start from quick. Then we select estimated var. Under the estimated var, there is a vector error correction. Vector error correction. If you are interested when these two variables are not co-integrated each other, then we can select the standard var and we select the variable here to estimate the vector autoregressive model, another option. But in the present case, all these two variables are co-integrated each other. Therefore, vector error correction model is the appropriate model. Here we select vector error correction model. And in the vector error correction model, here we specified the variable, the dependent and independent variable, or the two variables to understand the causality. Suppose GDP first and trade is the another variable. When we write GDP first, trade is the second, then trade is treated as the independent variable and GDP is treated as the dependent type of variable. But in case of result, we will see that here GDP on trade as well as GDP trade on GDP, both results will be available after estimation. Okay, this is the selection of the variable for the vector error correction model. That is my last model of estimation, because var is very simple type of model. When these two variables are not co-integrated each other, you select standardized var and select the variable to estimate the var model. That help us to estimate only short run causality. But vector error correction model is better than the not better. In the present case, for these two variables, vector error correction model is appropriate as they are co-integrated each other. Therefore, we are performing the vector error correction, the estimation of the vector error correction model. The first step is the selection of the variables to understand the short run and long run causality. First of GDP and then the trade. The lag intervals by default software considered as 1 and 2. There is no other selection required. That is the result. Like a vector error correction estimation. That is the result of the vector error correction estimation. Okay. How we can interpret this result? how we can interpret this result. In this result, the first equation, it is called co-integrating equation 1. This is called the co-integrating equation 1, and this coefficient or this information help us to understand whether there is any long-run causality or not, or to understand the short-run causality. The GDP lag 1, GDP lag 2, trade lag 1, trade lag 2 are important. We will consider this lagged data to understand 1 period and 2 period lag. 1 period 2 means short period lag. Therefore, this coefficient help us to understand short-run causality, whereas the coefficient corresponding co-integrating equation is treated as the help us to understand the long-run causality. I can summarize the result. In case of vector error correction model, it helps us to understand both short-run as well as long-run causality. The long-run causality can be understood by the coefficient of the co-integrating equation, whereas the short-run causality can be understood by the coefficient of the independent variables, say GDP first period lag and GDP second period lag, or trade first period lag or trade second period lag. Here we have considered GDP is the dependent variable, trade is the independent variable. Therefore, for the short-run causality, the coefficient of trade -1 and trade -2 are important. But here in the test result, under DGDP means it is the first difference of the GDP as the dependent variable. GDP is the dependent variable and trade is the independent variable, as we have considered in our, as we have specified in our selection of the vector error correction model. First step we write GDP, then we consider trade. But here this is the coefficient value, it is the standard error, and this one is the t value. The coefficient by standard error is actually the t value. Similarly, it is also true for the other variable. In case of GDP -1, it is the coefficient, standard error, and the t value. But probabilities are not available here. That is, level of significance of different variables are not given here. Our task is to find out the level of significance of the different coefficient. What are the number of coefficient in this model? 1, 2, 3, 4, 5. Another is the C. 6 here, and here software considered D trait as the if D trait is a dependent variable and GDP is an independent variable, then again there are 6 coefficient. Therefore, in this estimated result, there are altogether 12 coefficient. Our task is to find out their corresponding level of significance, because in the first result all information are there, but corresponding level of significance or probabilities are not available. We can estimate the level of probabilities of the different coefficient by using this method, PROC. And under the PROC, you can write the steps. PROC, there is the make system. Okay, make system. We consider make system, then order by variable. Order by variable. That is, we have specified the coefficient corresponding different variable. Order by variable. These are the equation. In case of first equation, when GDP is the dependent variable, this is the co-integrating equation. C2, C3, C4, C5, C6 is the general error, general constant. Similarly, in the second equation, where D trait is the dependent variable, this is the co-integrating equation, co-integrating coefficient, and from C8, C9, C10 to C12 are the other coefficient. Therefore, there are we have specified all 12 coefficient in our estimated result. What is our now our task is to estimate the corresponding probabilities. We can therefore we start from estimate, then it is the ordinary least square method, then okay. That help us, this process help us to find out the coefficient variable, their coefficient as well as their probabilities, the entire result. The same result previously we had obtained in the earlier page. Here C1, C2, C3, C4, C5, C12. What is the C1? The equation is specified at the bottom. C1 is the coefficient of the co-integrating term, and C4 and C5 are the coefficient of the independent variable. Trait is the independent variable. C4 is the coefficient of first period lag of independent variable, and C5 is the coefficient of the second period lag of the independent variable. As a first of our, we are interested to explain or interpret whether there is any long run causality or not. Long run causality between GDP and trait. That can be judged by the value of the coefficient. Here the value of coefficient is positive and it is statistically significant. That is true. But for the long run causality, if this particular coefficient is negative and statistically significant, then we can say that there is the long run causality running from trait. Trait is the independent variable, as we have considered, running from trait to the GDP. But in our estimated result, C1, the coefficient C1 is statistically significant. Probability value is 0.000, but its sign is positive. Therefore, we can say that there is no long run causality running from trait to GDP, running from trait to GDP. This is the interpretation for the long run causality or the coefficient 1. Okay, for the short run causality can be understood by the coefficient of the independent variable. One is trait, another trait first period lag, trait second period lag. That is C4 and C5. In case of C4, the coefficient is negative. In case of C5, it is the positive. We are not able to get the final conclusion. Therefore, here we will find out the joint effect of these two periods. That is joint effect of two consecutive periods to understand the short run causality running from trait to GDP. Trait to GDP. Okay, a particular statistics is there that is called Walt test statistics that help us to get the joint effect of these two coefficients C4 and C5. Why C4 and C5? If you consider more than one independent variable, then it is not C4 and C5. Here, from the estimating equation, the C4 and C5 are the coefficient of the independent variable, lag period 1, lag period 2. Therefore, we are interested to find out the joint effect of C4 and C5 to get, but to find the short run causality running from trait to GDP. Now we can try for the Walt test. What is the test? You write in your copy. It is Walt test. I have also mentioned in the PPT. Walt test help us to understand the joint effect of the independent variables. Here we start from view. Under the view, there is the coefficient diagnostic, and under the coefficient diagnostic, there is the Walt test. Walt coefficient test, or in brief, we say it. We call it Walt test. This Walt test help us to understand the joint effect. Here we write the coefficient restriction separately by commas. Coefficient means here under the null hypothesis, C4 and C5 are 0. That is, there is no effect of this coefficient on the dependent variable. And alternative hypothesis is, yes, if alternative is true, then C4 and C5 are different from 0. That is, there is a specific effect from independent variable to the dependent variable. Therefore, we write the null hypothesis in this way: C4 equal to 0 and C5 also C5 is also equal to 0. Sorry, C5 is also equal to 0. That is, under the null hypothesis, there is no effect of these two variables, trait minus 1 and trait minus 2. But if null hypothesis is not true, null hypothesis is rejected, then we can say that yes, their joint effect, there has some joint effect of these two coefficients. Therefore, we specify here the null hypothesis. Okay. This is the result of the wall test. Okay? This is the result of the wall test. It is the chi-square type of test. It is the estimated value of the chi-square, and this is the probability of this wall test. Probability is 0.002. Here the null hypothesis is C4 equal to C5 equal to 0. That means null hypothesis means equal to 0 of all the coefficient, all this coefficient. And here chi-square test is statistically significant. Therefore, what we can say, whether the null hypothesis is rejected or accepted. On the basis of the value of the chi-square test, what we can argue, whether the null hypothesis is rejected or accepted. Chi-square test is statistically significant. As chi-square test is statistically significant, therefore we can say that the null hypothesis is rejected. Null hypothesis is rejected means it is different from 0. These two coefficients are different from 0. That is, they have the finite impact. Finite value. Finite value means they have the finite impact on the dependent variable. If this wall test is statistically significant, then we can say that there is a short run causality running from independent variable, that is trait, to the GDP, running from trait to GDP. Okay. Therefore, in our present result, here the coefficient of the, what is the result? Yes. This is the result. Here the co-integrating equation, the coefficient of the co-integrating equation is positive, though it is significant, but as it is positive, therefore there is no long run causality running from trait to GDP. But the coefficient of two independent variables for two short period with log 1 and log 2 are different from 0. That is confirmed, that we have confirmed by the wall test. And we can say that there is the short run causality running from trait to GDP. This is the final conclusion of the vector error correction model. Okay, thank you all. Now, if you have any query or any clarification. Hello.
If we have large number of variables, then should we go for 2-3 variables at a time?
At a time,
more?
yes. In that case, in here we have two variables. Okay, therefore we have two column of estimating coefficient, GDP and trait. If you have three variables, then one is for GDP, one is for trait, another is for say inflation, INF, another is for number of equation or increases. Okay.
Yeah. So
but in that case, you should remember what would be the appropriate coefficient. That is important. You count the appropriate number of coefficient is starting from here: C1, C2, C3, C4, C5. Then if there is another independent variable, then again it is C6 and C7. Then again C8. If three variables you have taken together, you will taking together. Then there are 8 coefficient for a particular test, for a particular line. Clear?
So it is suggested to go with many variables at a time, like 10-15 variables?
No. 10-15 variable are not possible, because you are not able to find this 10 or 15 variable. All are stationary at order 1 and all are co-integrated.
Yes.
Yes. Before using the VECM, the precondition is that they are stationary. The variable are stationary side by side. They are co-integrated in the same order. Here, these two variable, I have considered 5 variable, and I have checked among these 5 variable, only these 2 variable are co-integrated in order 1. Therefore, we can consider these 2 variable. But in your data case, if 2 or 3 or 4 variable may be integrated in order 1, you can consider this variable at a time. Or you can consider other. You can consider 2 or 3 separate estimation. That is not the issue.
Sir, is there any ratio for like number of years and how many variables should be taken?
No. In case of VECM model, vector error correction model, the restriction of the the restriction of the T and N are not important. There is no restriction about T and N. But generally, as they are the time series types of test, number of time years sufficiently large. Number of times must be sufficiently large.
Some suggested that 1:5 should be there.
No. These types of specifications are not possible. If you have the data of 2 cross-section units and you have the data of 1:2 and 10 time period data, then these types of short panel data are not fit for the panel unit to test or co-integration test or vector error correction model. Your data must be sufficiently large. Otherwise, you are not able to find out the causality. Causality means long run association. As you are interested to find out long run association, your time period must be larger. Therefore, 5 is the very short time period. That does not indicate the long run. Clear?
So, it should be more than 5 years or even larger?
Even larger. The larger the time period, the efficient, you will find the most efficient or most robust coefficient. Okay, if the time period is relatively less, your estimated coefficient are not robust. Therefore, as large as possible is the criteria for any time series test as well as panel data test for the causality, for the long run causality.
Like said, there are some new initiative taken in the company, and we are trying to see the difference. And it was not implemented, and then it was implemented. So implemented period is like 7 years, 8 years. So in that case, should we go for this?
Yes, in that case, long run causality is not important. In that case, short run causality.
Yes.
You'll find the short run causality. Short run causality is also important. In for your data set, you are able to interpret short run causality. Yeah.
Another is that if we have some dummy variable like 0, 1 type, some scheme is present in the company or not.
No, so, you are not able to estimate here, because if you dummy variable, then when taking the first difference, it has no meaning. Therefore,
yes,
the dummy variable are not used for the to analyze the causality.
Analyze
the causality. It can use in case of static panel data regression equation. That is true, but they are not used in case of short run or long run causality, because all the variable are taking after first difference, DGDP or D rate after first difference. If we consider dummy variable after first difference, it has no meaning.
Yes, sir. Thank you so much.
Thank you. Achha, any
other queries?
যদি বাংলায় চাইলে in Bengali তো জিজ্ঞেস করতে পারবো আর কি. I understand the Bengali.
Any other queries?
Any other queries?
I think there is no more queries, sir. It was a wonderful deliberation, sir.
Okay. Thank you.
Yeah, and a number of appreciation are coming in chat box.
Okay. Thank you.
So I quickly request Harunama ji to please provide the vote of thanks to sir. Harunama ji. Yeah.
Okay, sir. Being the co-convener of today's FDP, I deem it a great honor and privilege to propose the vote of thanks on this memorable faculty development program. Let me first of all start by giving glory to the Almighty God for making today's session a resounding success. Today, I take this opportunity to express my deepest sense of gratitude and appreciation to all those who made this event such a resounding success. To begin on behalf of the Department of Management of Assam University, Silchar, and Vidyasagar University, West Bengal, and all the research scholars and faculties, I would like to thank our resource person, Dr. Pinaki Das sir, who spared time from his busy schedule to grace this faculty development program. Thank you, sir. Now I place on record our gratitude to our respected Dean Professor A.L. Ghosh sir, our head of the department, Professor H.R. Singh sir, and our respected Dr. Dibjyoti Chaudhary sir for their generous support for this event. Dr. Dibjyoti sir, your encouragement has constantly boosted all our endeavor. Thank you, Dr. Dibjyoti sir, for your unstained support. Now, I would like to thank our beloved co-host, Savanti ma'am, Buddhista sir, Tilaknath Sahu sir, Vicky Sharma sir. My heartfelt thanks to all the head of the various department and the faculty for their valuable contribution, guidance, and engagement in all our efforts. Last but not the least, I thank the host and host for their relentless effort and my friends for their cooperation in making this function a resounding success. Thank you everyone.
Thank you. Okay, now I can leave, I think.
You're mute.
Devajyoti sir. I am unmuted.
Dibjyoti sir, you are mute.
Sir, thank you for your delivery.
Okay.
We would like to listen to you again in future, sir.
Okay, thank you.
Thank you, sir. Thank you. Yeah.
And could you provide the email if possible?
Email, yes, I write in the chat box.
You can write in the chat box so that they can take it.
That should be
So participants, we are meeting again at 6:30 for the next session.
vidasvu@mail.vidyasagar.ac.in. Okay, my email ID. Thank you all again.
Thank you, sir.
Okay, thank you, sir.
Dear participants, please wait for 5 minutes. Our resource person will be joining soon. Thank you.
Dear participants, there has been a sudden problem from the resource person end, and he will not be able to join. So what we are doing is that we are arranging another substitute resource person, and maybe there will be a little bit change in the topic. So just give us 10 minutes, and within 10 minutes, we may start the session. Please have patience. Thank you.